The increased demand for spectrum also raises questions about whether spectrum can be shared more efficiently. Low-power, unlicensed uses provide one example of spectrum sharing. For many, unlicensed devices operate on the same frequency as other services. But many observers see the potential for far broader sharing, including high-power uses, to make more efficient use of the spectrum. Spectrum sharing is often raised as a possible solution to the seemingly intractable problem of how to recapture spectrum from government agencies that don't use their spectrum efficiently. To a great extent, more extensive spectrum sharing depends on technological developments. One such development is cognitive radio technology, which allows a secondary user of spectrum to detect whether the primary user of spectrum is active. If the primary user is not active, the secondary user can operate. 5.8 GHz Wi-Fi devices provide an example. They operate in the same frequency range as military radars, but are equipped with technology that enables them to detect such use and to avoid any conflict. Other radio technologies can avoid interference not by sensing a conflicting use in real time, but by accessing a database of spectrum usage. More efficient use of spectrum may also depend on receiver technology. To date, the FCC's approach to spectrum management has relied almost entirely on transmission, on assigning a frequency within a particular geographic area with limitations on power. Because the FCC doesn't regulate receivers, claims that a service will cause harmful interference sometimes arise not because the transmitter sends a signal outside of its designated band, but because the poor quality of a receiver allows it to pick up signals from frequencies other than the ones it's designed to receive. There's significant unmet demand for spectrum. There's no way to create new spectrum. But spectrum scarcity as we know it is largely a creature of regulation, a legacy of the historical model of spectrum management first introduced more than 100 years ago. What remains to be seen is whether technological developments and modified approaches to spectrum management can ease that spectrum scarcity.